This lesson is looking at linear and nonlinear equations and functions. All right, inside of the linear section, instead of looking at this in terms of slope and an intercept, we're going to look at it with x and y values. And we're going to look to determine if it's going to be linear or nonlinear. So x, let's call it 0, 1, 2, and 3. And I need to determine my y. So this is my input for x, and my output is y. Oops, sorry. So if I plug in 0, 3 times 0 minus 2 is negative 2. 3 times 1 minus 2 is 1. 3 times 2 minus 2 is 4. And 3 times 3 minus 2 is 7. And now let's graph those ordered pairs. And this, I can see, is linear because it makes a straight line. We're going to do the same thing in number 2. We're going to use the value x and y values. We have x is 0, 1, 2, and 3. Now I'm just making those numbers up. I can put anything in, hence the I for input, and then the O for output. So plugging in 0, 1/2 times 0 plus 3 is 3. I plug in 1 times 1/2 plus 3 is 3.5. I plug in 2 times 1/2 plus 3, I get 4. And 3 times 1/2 plus 3, I get 4.5. And then you can plot those points. Good. And it is linear. 3. We're going to use x and y values. We use the same x values. You got to figure out your y values. Plugging in 0 times negative 2 plus 4 is 4. 1 times negative 2 plus 4 is 2. 2 times negative 2 plus 4 is 0. And 3 times negative 2 plus 4 is negative 2. See if it's linear or nonlinear. This makes a straight line, so it's linear. And then we have our last problem. You can pause the video and try this one. Your x values, you can make them up. We're just going to keep them consistent. We want to make sure we can see all the points on the graph. So I'm going to plug in 0 minus 3, it's negative 3. 1 minus 3, negative 2. 2 minus 3, negative 1. And 3 minus 3 is 0. Also linear. Linear equation, linear function. Linear functions will always be written in y equals mx plus b form. And that's exactly how all 4 of these are written. Look at number 5. The temperature at dawn was 52 degrees, and it increased steadily 3 degrees every, meaning multiplying, hour. Write an equation and graph the relationship. Well, the temperature, or y, depended on it went 3 degrees every hour, so that's 3 times h or x, or just 3x, and there was that constant of 52 that it started at. And we're going to create a table to determine the temperature after dawn. Well, at dawn, plug in 0, we know it was 52 degrees. 1 hour later, it was plug in 1, 55 degrees. 2 hours later, it's 58 degrees. And 3 times 3 plus 52 is 61. So I can just graph that here. Extend your graph. Okay. Nonlinear equations. You'll notice that we have, it almost looks like slope-intercept form, but now I have an exponent. Okay, so let's see what happens to our graph. If my x values are -2, -1, 0, 1, and 2, and I'm doing x squared plus 1, what is y going to be? So plug in -2 squared plus 1. It's going to give us 5. -1 squared plus 1 is 2. 0 squared plus 1 is 1. 1 squared plus 1 is 2. And 2 squared plus 1 is 5. And now graph your points. So we have -2, 5, -1, 2, 0, 1, 1, 2, and 2, 5. -1, 2, 0, 1, 1, 2, 2, 5. Connect your dots. Okay? This is called a parabola. That's the shape, that U shape. Parabola. And we know that anything with an exponent of 2, this is called a quadratic equation. A quadratic equation with that exponent will give us that parabola shape. This is nonlinear. Okay. So let's do this similar thing over here with number 7. -2, -1, 0, 1, and 2. I'm going to plug it into x cubed minus 2 to get y. So -2 cubed minus 2, -1 cubed minus 2, 0 cubed minus 2, 1 cubed minus 2, and 2 cubed minus 2. Now you can pause the video to compute that. We have -10, -3, -2, -1, and 6. Okay, so making those ordered pairs. -1, oh, this should have been -10. -1, -3, 0, -2, 1, -1, and 2, 6. Okay? And this is a cubic equation, or cubic function. This was quadratic function. And that's the shape of every cubic function. It is not a straight line, it is a curlicue. And then number 8, you should be able to try on your own. We're going to start our x's. We have square tiles and side lengths. I can't have 0 or negative side lengths, so I'm going to start with 1. And I'm going to substitute it in for x. 1 squared, 2 squared, 3 squared, and 4 squared. And then I have my ordered pairs. And connect your dots. I know that this will be if there were such thing as negative side lengths of a square, this would be a parabola because this is a quadratic equation because it has the squared on the x.